Here we are again, another pre-calc lesson. This one is lesson 28, factorial notation and abstract rate problems. Factorial notation is an exclamation point because we're so excited about it. It looks like n is a number, factorial. And what it is we do n times n minus 1 times n minus 2 times n minus 3, until we get down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. And you multiply that out, and you would get a number which is 120. That is factorial notation. So here's our examples. That was exactly example 1. Let's look at another example. 9 factorial over 3 factorial times 5 factorial. Now, let's write it out. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 9 factorial. 3 factorial is 3 times 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. Now, if we notice, on top, we have 5 times 4 times 3 times 2 times 1, as well as on bottom. So those cancel. And 3 times 2 gives me 6, so it cancels here. So really, we have 9 times 8 times 7, which is just 504. Okay, let's do another example. 14 factorial over 6 factorial times 11 factorial. Now, what I'm going to do is 14 times 13 times 12 times 11 factorial over 6 factorial times 11 factorial, because my 11 factorials cancel. I don't even have to write out all 14 numbers. So I have 14 times 13 times 12 over 6 factorial. Now I know that 6 times 2 gives me 12, so I can cancel that. So really I have 14 times 13 over 5 times 4 times 3, which is it gives me 91 over 30. Fraction. Okay, that's factorial notation. We're going to do a lot of different stuff with that further on in the book. Let's talk about abstract rate. These we will see a lot this year. I think it's one of the harder lessons that we have. But abstract rate problems are where the statement of the problem defines two components which allows the third to be calculated. Okay, we will have change that is made in one or two components. And then we solve for the third component, or third piece. Okay, so let's look at an example. The train travels m miles at p miles per hour and still arrived an hour late. How fast should the train have gone to arrive on time? All right, so we are doing abstract rate problems, meaning distance equals rate times time. Okay, and we know that our original distance, our distance 1 is m miles. Our rate 1 is p miles per hour. Okay, and we are looking for our time. Now, distance equals rate times time, so time is distance over rate. So my time 1 is my distance m miles over my rate p miles per hour, which gives me m over p hours. Okay. Now, how fast should the train travel to right on time? So I have my new distance is the same, right? I haven't changed. I'm still going the same distance. My new time, right? I was an hour late, meaning I'm going to go an hour faster. So my new time will be my old time minus 1 hour. Okay? And I'm looking for how fast. Rate is distance over time. So my rate is going to be distance over time. This is going to be miles per hour. Now I need to simplify this. We know we can't have a fraction over a fraction. So I'm going to combine my numerator into one fraction. So my rate is m over m minus p over p, which if I have a fraction in the denominator, I multiply by the reciprocal, giving me mp over m minus p miles per hour. Okay? It helps to list everything out. I want you to do that. I want you to write out your original distances. I want you to write out your new distances and original rates, new rates, original times, new times. Figure out what you're solving for. These will be very hard. These will be some of the hardest problems you will see, okay? Let's do another example. The boat traveled k miles in t hours and was 40 miles short of the goal. If the skipper, try it again, how long would it take to reach the goal if she increased the rate by 10 miles per hour? All right, so distance is rate times time. My first distance is k miles, and my first time is t hours. And my first rate, because rate is distance over time, is k over t miles per hour. Okay, now I was 40 miles short of the goal, which means if I want to reach the goal, my second distance will be k plus 40 miles, because I have to go 40 more miles to get to my goal. Okay, now I'm looking for time. How long will it take? And I've increased my rate from k over t. I've increased it by 10 miles per hour. Now I'm going to combine this into one fraction here to make it easier. So this will be k plus 10t all over t. Okay, now I know that time is distance over rate. So I will have k plus 40 over k plus 10t over t. I know this is in hours. I have a fraction in my denominator, so I'm going to multiply by the reciprocal, t over k plus 10t on top and bottom, leaving me with k times k plus 40 over k plus 10t hours. Oh, sorry, this should be a t. This is k plus 40 times t over k plus 10t hours. Sorry, this is t in the numerator here. You don't need to multiply through your t on top. You can leave it exactly like this, but make sure you have your units. You have to have units. Okay, that will be part of the points that you will receive. The whole key in this is that we are manipulating distance equals rate times time. All right, we will have plenty of practice with this tomorrow, but for now you can get to the rest of your homework.